Alrighty, and welcome to day 2 of hyperbolas. We have one objective in today's tutorial, and that is to write the equation of our hyperbolas in standard form. So let's flip over. 9.4b. Okay, so let's first review the two standard forms for our hyperbolas. First, let's talk about the horizontal hyperbola. The horizontal hyperbola standard form is x minus h quantity squared divided by a squared minus y minus k quantity squared divided by b squared, all equal to 1. The vertical standard form for a hyperbola is y minus k quantity squared divided by a squared minus x minus h quantity squared divided by b squared equal to 1. Okay, so if we're looking at these two standard forms, and this is what we're going to be trying to get our equations to become today, it's clear that we really just need three things. What we need is the center. That will give us h and k, and basically that will give us the tops of our quantities of our equations. Watch out for the vertical one because h is with the x over here and k is with the y over here. So we do need h and k. We'll need the value of a, and we'll need the value of b. Once we have these three things, the center, a, and b, we should be able to plug right into our standard forms and we'll have our answers. So if we look at our first example, we are to write the equation of the hyperbola with center at the origin that has one focus at 4, 0 and one vertex at negative 3, 0. All right, well, we're given the center, so that's kind of nice. We know that the center is 0, 0. Let's go ahead and plot that. I'm also going to label that with a C so that I can keep my points in order. So the C, the center is 0, 0. Let's go switch color. The focus is at 4, 0, so 1, 2, 3, 4 units over here is where one of the focal points is. And now we know right now that we have a horizontal hyperbola. We could also put another focal point over here if we wanted to. So I know that it's horizontal. As soon as I know that, I'm going to write that standard form down. Horizontal, so we're talking about x minus h quantity squared divided by divided by a squared minus y minus k quantity squared divided by b squared, all equal to 1. Okay, so I know that that's the standard form that I'm trying to get to. We know one other piece of information. One of the vertices is at negative 3, 0. Let's not do that in blue. Let's do that in a different color. Here we go. Fuchsia. Negative 3, 0. 1, 2, negative 3. And that was a vertex, so I'll label that right there. Okay, so we already know the tops of our equations. We know that h is 0. We know that that k is 0. So we have the tops. We've got, well, I'll just go ahead and do 8x minus h squared, x minus 0 squared, and y minus 0 squared. That might be my preliminary step. Of course, those are going to turn into just simply x squared and y squared. So I know that. It's all about finding the denominators. I need the value of a, I need the value of b. From my graph, at least from what I've plotted, I know that a is the distance from the center to the vertex. It doesn't matter if I'm going in the positive or negative direction, we're always just taking the value, the absolute value. And that distance here is 3 units. So that means that a is 3. That's very helpful. Obviously, I'm going to go ahead and square that and put that into our standard form, so I'll have 9 underneath that. So we're almost done. We just have the b squared that we need. Okay, unfortunately, we don't know what b is. We don't have any asymptotes. We don't have anything up and down here. So the only other piece of information we have is what the value of c is. And the value of c is the distance from the center to one of the focal points, which in this case is 4. So we do know that c is 4. What we do not know is b. But we do know the relationship between a, b, and c. For a hyperbola, c is equal to the square root of a squared plus b squared. So I can plug these numbers into this equation, and I know that c, which is 4, will be equal to the square root of a squared, which is 9, plus b squared. The only unknown right now is what b is, or what b squared is. Since there's a square root there, I'm going to go ahead and undo that by taking the square, by squaring both sides. Square and a square root cancels out. We get 16 is equal to 9 plus b squared. And when I subtract my 9, I'll have that b squared is equal to 7. You could go and continue to find b if you needed b to go and finish your graph, but right now I'm basically finished. I just need to know what b squared is. B squared is 7, so I'm finished with the standard form for this hyperbola. Excellent. All right, let's move on to the next one. Okay, so in this next one, we're to write the equation of the hyperbola with center at 1, -2, one focus at 4, -2, and one vertex at 3, -2. Pretty similar problem to the last one. This time our h and k are, of course, different. They're 1 and -2. Let's go ahead and plot that. Let's see, 1, -2 would be right here. I'm going to label that with a C. I'm going to put my focus at 4, -2. So let's count out 1, 2, 3, 4, -2. I'll label that with an F. And again, instantly I know since we're working laterally, we're working along the x-axis, this is horizontal. This is a horizontal hyperbola. Again, horizontal, x minus h quantity squared divided by a squared. I always like to put the standard form with all the unknowns in it, and I'll plug right into that. Okay, which means actually I can go ahead and go straight to the top. I know that h is 1, so this becomes x minus 1 quantity squared. And I know that k is -2, so this is y plus 2 quantity squared, all equal to 1. This is y net minus -2. Y minus -2 actually makes a positive, so there we go. We're looking for a squared, we're looking for b squared. I do have one more piece of information. I'm doing that in purple. The vertex, or one of the vertices at least, is at 3, -2. All right, so there's my vertex. So now I can count out my distances. I know that the center to the vertex is right here, and that's 2 units. That's my value of A. A is 2. I know that the center to the focal point is 3 units, and that's the value of C. And again, what I don't have is the value of B. But I can use our relationship that C is the square root of A squared plus B squared for a hyperbola. So since C is 3, this becomes 3 equals, and A squared would be 4 plus B squared. And then I can go ahead and solve this little equation. We'll square both sides. Squaring a square root undoes and gets 4 plus B squared to come out. And 3 squared, of course, is 9. I'll subtract my 4. And I'll do my symmetric property as well. I'll bring the B squared right here. And 9 minus 4, of course, is 5. So I have my b squared. I know that since this is horizontal, the b squared is with the y. So b squared will go right on here. It's 5. And I'm missing a squared, but I think I have a over here, and I do. So I'm going to go ahead and square this to put this into our equation right here. And 2 squared, of course, is 4. Remember, with a hyperbola, it does not matter what the denominators are. In fact, they could be the same number. What matters is that the x term comes first for the horizontal hyperbolas. The y term would be first for a vertical. It's all dependent on which term comes first for the hyperbola. Unlike the ellipse, which depended, first of all, had a big plus sign here for the ellipse, and it depended on which denominator was bigger. Okay. So we are finished with this one. Let's look over at our third problem. Okay, so here's our final example. This is to write the equation of the hyperbola with vertices at 0, -6 and 0, +6, and one asymptote is y equals y equals +2x. Oh, interesting. We don't even have the center here. Well, let's graph the two vertices. Let's plot those in. 0, negative 6. That's going to be 1, 2, 3, 4, 5, negative 6 units down here. I'll put a V. And 0, positive 6. Well, that's just 6 units above. 1, 2, 3, 4, 5, 6. And there's a V. Just given that information, I instantly know we're talking about a vertical hyperbola. Okay, so we got a vertical one here. Let's put the standard form down. Vertical, and that means that the y term is going to be coming first. Y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. Unfortunately, I don't have H, I don't have K, I don't have A, although I think I do, and I don't have B yet. So let's find this out. Actually, I'm pretty sure I know where the center is. The center is going to be exactly in the middle of our two vertices. And since it's exactly 6 units up from the origin and 6 units down from the origin, I know that my center is right there. So my center this time is 0, 0. So that means that the tops of my equation is, they're pretty easy. Y squared and x squared. That's not too bad. Okay, the other piece of information I have not yet used are my asymptotes. Y equals 2x is one of my two asymptotes. Let's graph that. Y equals 2x plus 0. So we have a 0, 0 is one of the points, and then a slope of 2. So, and that's of course 2 over 1, if that helps you. So up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1. I'm finished over there, but I can go down 2 and left 1. That's still a positive. Down is negative divided by left, which is negative. Negative divided by negative is still positive. Down 2, left 1, down 2, left 1. Okay, so this is one of our asymptotes. Okay. The other asymptote must have a slope of y equals negative 2x, or negative 2 over 1x, plus 0. So that means that the other asymptote is right here, down to right 1, down to right 1, down to right 1, down to right 1, up to left 1, up to left 1, up to left 1, up to left 1, and we can dot that in. I'm just doing this just to practice our graphing our asymptotes. Right. And that means that I can actually graph the rest of this curve if I wanted to, which I'm going to. I've got my two vertices. That means that the hyperbola does this up here, getting closer and closer to our asymptotes without touching them, please. And there we go. Okay, great. So let's talk about writing the equation, which is where we're supposed to be going anyway. So I do know what A is. I know that A is the distance from the vertex to the center, from the center to the vertex, and we all know that that's 6. So A is equal to 6. I know that I can go plug that into my standard form and square it. A squared goes right in here, so that's going to be 36. Excellent. I'm still looking for B squared. And really the only thing, I don't have a focal point this time, so I can't figure out what C is, so I can't use that relationship. But what I do know is that the slope of one of our asymptotes is 2. So I know that the slope of a vertical hyperbola, the slope is going to be A divided by B. I remember that because it's the y's over the x's for slope, and the A attaches to the y, and the B attaches to the x. So A divided by B. I know that the slope is A divided by B for one of our asymptotes. And that is equal to, if you can do this, this is 2 over 1, so I can see both parts of the fraction. This does not mean that A is 2 and B is 1. That's one of the possibilities, but couldn't A be 20 and B be 10? 20 divided by 10 would also be 2. A could be 2,000 and B could be 1,000. A could be 36 and B could be 18. As long as A is exactly 2 times B, then we know that it's going to reduce to 2 over 1. So please don't misunderstand this proportion. A does not have to be 2, B does not have to be 1. In fact, we already know what A is, and that it's not 2. A is 6. If A is 6, then we know that 6 divided by B is equal to 2 divided by 1. Do we now know what b has to be? I hope you're thinking that b has to be 3, because that would be right. If you want to do your cross multiply, which is the way to solve a proportion, you can get 2 times b is equal to 6, and therefore b is equal to 3. If b is equal to 3, b squared is equal to 9, and that's what I want to put into my equation, 9. Let me go through that again. This is our final answer for the standard form. I know that the slope of this asymptote is 2, or rather 2 over 1. So I'm saying that the slope is a over b, which is 2 over 1. Again, it's a over b because a attaches to the y, b attaches to the x, and slope is the rise divided by the run. So a over b. A over b equals 2 over 1. Since I knew that a was 6 to begin with, I know that 6 divided by some number had to be 2, and therefore that b simply had to be 3. And you could cross multiply to go and figure that out. And then, of course, I squared the b to put it into my equation where everything is squared. That's it. I'd like to end this lesson with 3 try problems. I would like for you to pause the lesson at this point so that you can try these yourselves. Please pause and you can come back and check the answers. Pause now. Thank you. I'm not going to give you the answers yet. If you have not yet done this, please pause right now. You've only been watching for about 16 minutes. I'm sure that you can invest about 3 more minutes per problem, another 9 minutes into this. Please try this by yourself and then unpause so you can see the answers. I'll be back. Alrighty, and here are our final answers now. So hopefully you got these 3 answers. If you were having trouble finding the center in this third one, a neat little trick, since they gave you one of the asymptotes, the equation of one of the asymptotes, and they're using their point slope form, you know that this has to be the quantity for the x, so x minus 1 quantity squared, and this has to be the quantity for the y, so y plus 1 quantity squared. So they almost give away the top of the, they do give away the tops of your standard form equation here. Okay, don't forget you have a minus sign in each one of these because they are hyperbolas, and please make sure you have the correct term coming first. The top one was a vertical one, and the other 2 were horizontal ones. Thank you very much for watching this tutorial, and we'll see you in class so we can practice this some more. Bye-bye.